Hi everyone, and welcome to today's webinar about maximizing the offsite advantage with our digital solutions, MWF and ONYX. My name is Michael James. I'm a technical specialist at Strucsoft Solutions, part of the Greytech Group. In today's presentation, I'm excited to talk about what is offsite construction and the benefits of offsite, modular and prefab. I'm also going to go into MWF where I'll do a live demonstration showing some of the benefits of our tool. And following that, I'll jump into ONYX, where again we'll look at some of the features and some of the benefits of the tool as well. So, what is offsite construction? You may have also heard the terms modular construction or prefabrication, which all fall under the same umbrella of offsite construction. And while these terms differ slightly, they all point to the same idea. As the name suggests, offsite construction is a fabrication or manufacturing and assembly of building elements at a location away from the final construction site. Typically, this means a factory equipped with manufacturing equipment where components are produced and assembled rapidly and then transported to the job site. The idea behind offsite construction isn't new, but by taking advantage of technological advancements such as software solutions, CNC machinery, and robotics, the innovative method of construction has transformed itself into a valid substitute for traditional site-built construction methods. So as you can see in these images, on the top left, you can see we have a wall panel that was prefabricated in a factory and then shipped to the job site for installation. The other two images show fully constructed sections of a building known as modules, and this is where the term modular construction is derived from. And these modules are stacked in place, much like Lego bricks. The great thing about offsite construction is that it's used for all kinds of projects, including residential, commercial, and mixed use. Its applications are virtually endless. In certain cases, you'll see a mixture of traditional site-built construction and offsite construction, where only certain components, such as the wall panel, are manufactured in a factory, while the majority of the structure is built on site. So let's look at some of the improvements and benefits that can be realized by the builder by deploying some offsite techniques. Firstly, by moving a large portion of their work from an open setting with limited working hours into a controlled indoor facility with 24/7 production potential, offsite construction offers various benefits, such as a faster process. As offsite construction is factory-based, the on-site construction time is reduced drastically. Weather factors like rain, snow, and winds no longer hinder the construction process, and panelized framing can be done for walls, floors, and roofs with their respective wood or metal studs. The panels are assembled within a factory environment, each having all members cut and fixed together, then delivered to site. This flexibility with delivery makes panelized framing a strong contender for sites with tight or restricted access. Additionally, as the product has already been pre-assembled, installation can begin immediately once brought to site. Another benefit is less waste and more eco-friendly. Due to the increased control of the construction process and improved precision, construction waste and workers' carbon footprint is decreased. Not only that, but due to the well-designed modular nature of offsite construction methods, reusability of building materials is also possible. In some cases, units, rooms, or even entire floors can be preserved and repurposed, ultimately reducing the potential landfill waste. So as well as the benefits mentioned previously, we also have lower cost. The controlled weatherproof workplace allows for lean manufacturing, which means more savings that can be reinvested or given to customers. Since most of the building is created in a factory, workers do not have to worry about seasonal work. This in turn creates a more stable environment and steady wages, making construction jobs more desirable. Additionally, in a controlled factory environment, more effective health and safety measures can be implemented, as building indoors mitigates some potential risks inherent with subcontractors and the number of site accidents. So another effect or another benefit of offsite construction is higher quality control. Thanks to a controlled environment and regular quality checks, a higher quality assurance system can be put in place, in the design and factory. Materials used are all machine produced and have little to no human interference, unlike traditional construction. With framing software like Revit and MWF, every inch of the project can be visualized and checked for errors before production. Roll formers are able to input this information, produce accurate framing and sheathing with insulation, and finally have the product ready for on-site assembly. This simple workflow allows companies to enforce higher control over the end product and end result. Here in this slide, you can see a direct comparison between traditional construction methods versus 3D volumetric. So one of the benefits is a 20% faster design to production, and the design to production time is greatly reduced by keeping the framing data in Revit versus solutions that require a third-party platform for fabrication drawings. There's a 42% faster fabrication drawing production, and 3D model parameters and drafting automation reduce the completion time of 2D fabrication drawings by reducing errors and change orders. So we'll see 10% improvement on productivity savings. If we refer to the table, you'll see that we can start laying the foundations at the same time or simultaneously while we produce the panels. As the panels are being generated off-site, these will not affect the laying of the foundations, and these two tasks can be carried out at the same time, which improves the overall time and productivity. We have 90% waste reduction. This can be realized through the accurate CNC output control and editing in a 3D environment versus the manual check and edit process in older systems. We'll also see a 20 to 50% increase in faster build rate. A project can be completed 20 to 50% faster using modular offsite methods compared to those used in traditional construction. This is due to the elements being constructed in the factory environment, and the processes can be automated and carried out a lot faster in a factory environment. So when we think about offsite construction and what it represents, we think of all the benefits of how it can boost productivity, save time, and streamline repetitive tasks. I'm going to show you a range of tools that exhibit those same qualities through the use of MWF. I'm going to start by using the Quick Create tool, which will aid us in the creation of panels and reduce the amount of time it takes to produce our panels across a whole project. With the use of some templates and some predefined settings, we can automate the placement of the panels by mapping our wall types to our templates. So if I go into MWF, into template map, I can simply select a template which has been predefined, and from there we have a range of wall types which we can map to our MWF templates. From there we simply select our walls and hit Quick Create. So this tool automates the framing process to ultimately reduce modeling time. And once complete, you can see that it's framed all of these different types of walls at the click of a button. If I were to relate this to offsite construction, I'd say that we're implementing time savings through modeling and automation, and this is something that we can also do when we compare offsite construction to traditional construction methods. So now we'll take a look at the modular tool, where we can see how this can also be used to boost efficiency in our workflows. So when using the modular tools, we can frame multiple units or panels that share common features and characteristics. This can be done quickly and effortlessly with a selection of modular commands. Again, in offsite construction, generating multiple elements in a short space of time is one of the key benefits of implementing these offsite construction techniques. So what I'm going to start by doing is selecting one of these modules. These units all share common features, utilizing the same panels over and over again. Again, we can use the Quick Create tools. First, point towards our template map, select the appropriate template map, and go ahead and hit Quick Create. So we can utilize this tool in a way that will supercharge our quick create tool or quick create feature by applying our settings to multiple modules at once across a project. This can be used on individual panels. This can be used on whole units. The tool has a few different features that we can use to match properties, copy elements, and ultimately delete elements when we no longer need them. And as mentioned before, one of the key benefits of offsite construction is the ability to generate multiple elements in a short space of time. Once complete, we can see that multiple walls have been panelized within this unit. So now these panels have successfully framed using the modular tools. You'll see that the original unit that we selected is now framed. So what I'm going to do is copy the members from this original group and have them applied to the remaining groups. So I'm going to go into modular and use copy members on all identical groups. We can choose our naming convention, so we can keep it consistent with the panels that they were the original panels that these new panels will be generated from, and we can share the same name by using same as original. Otherwise, we can continue the numbering and have each panel have its own independent identification number. We can choose to set the original panels as the parent panels, and if we were to lock our panels to a template, we could use the parent panels to regenerate the new settings or generate the new settings. So now these additional units have been completed, you can see that they are consistent with the original panels that they were generated from in this modular unit. This also ties into offsite construction in the way that we can generate these 3D volumetric and panels and elements and mass produce them in a short amount of time. What I'm going to do now is show you how we can make a modification to one of these elements within one of the units and apply the changes consistently to the other units. So I can go into the panel properties, miscellaneous, and make a quick change. So we're looking at a door, and we want to add an additional king member on the door. Now you can see the additional member that's been added either side of the door opening. We can now apply these changes to the other units. So if I refer to this unit here, you can see that we don't have the additional members around the opening. So what I can do is I can select this unit and still apply the changes made in my other modular unit and have them applied to this panel in the same way. So in modular, we have a tool called match properties, and we can do this for all panels which share the same group, or we can select individual elements and apply the settings. Okay, so I want to select this unit first, and then from there I want to say match properties from group, and I want to take the properties from this group. Again, I've got the option to change the numbering convention. For now, I'm going to click OK. So now those changes have been applied, we can check that the new unit now shares the same properties. So you can see here that the panel properties have been moved across to this panel, and we can match the properties across different modular units. Next, we'll take a look at another tool which I believe is great for boosting productivity and reducing tedious and repetitive tasks. So this tool is called clash detection, and here we have a model where some pipes are passing through our panel members, and there are some ducts passing through the face of the wall as well. So what I'm going to do is run the clash tool to prevent the clashes between these elements. To do this manually, this would be a very time-consuming task, as we'd have to make sure there are holes punched in every single member. We'd have to check the the whole type, and if there were any changes, so for example, if we had to move one of the elements or any of the elements in the model, we'd have to make sure we coordinate the holes with the new location of those elements. What we can do is we can select, first of all, the ducts and the walls where the ducts are passing through. From there, we have a dedicated interference menu where we can run the interference check. It's going to run clash detection, and this will allow me to clash my wall against any of these selected categories. We can also clash linked models as well, so if you're working with an MEP model provided by a third party, we can clash that third party model against our walls in our current model. All I'm going to do now is hit the blue tick. It's going to ask me to define a tolerance around the clashing element. In this case, we have these two ducts which are passing through the wall. MWF is intelligent enough to detect the size of the duct, where the penetration is, and add a tolerance around the element. So I'm going to add a tolerance on the left, around the right hand side, top and bottom. As we've got multiple openings which we're generating, so we're generating an opening here and another opening on the opposite side, I want to use the same settings on the other side as well. So as we zoom in, you'll see an opening has been placed where the duct is passing through the wall. All we have to do then is regenerate the panel in order to show the new members or frame around the opening. This can also be done on the opposite side. So now we have another scenario where we have our pipes which are passing through the wall and passing through our stud work. We want to prevent this kind of clash, and to do so manually would take a lot of time. What we can do is we can really streamline this task by utilizing our interference MEP clash tool. So what I'm going to do is select all the panels where the pipework is passing through. And we can go to MWF and simply click on the interference tool and run the MEP clash test. Here's my definition. I'm just going to use this to run the test. And based on our settings, 33 holes have been generated or punched through the stud work. So what I'm going to do is isolate my stud work, where we can take a closer look at where those holes have been punched. So you can see there are holes generated in these locations. And they've been punched automatically. Another tool that's great for productivity and saving a lot of time on a project is the ability to split walls or split panels within a wall. In some cases, you may receive a model from a third party, and the wall lengths may be too long for you to work with when it comes to transport and delivery of panels to site. In that case, we can set a maximum panel size, and we can split our panels down into smaller lengths so we can then transport them successfully to site. Here in this example, we have an extremely long wall here, and we have another long wall just to the bottom of this model in this example. We can split in two different ways, and first I'm going to show you a method that we can use to split this wall. So first I'm going to select the wall, go to MWF, and in the markers menu, we have a range of options allowing us to split the panel into smaller portions. I'm going to use this vertical split by rule, which will give me the flexibility to set the maximum and minimum panel sizes. I'm going to leave the sizes set to 10 feet and the minimum panel size set to 2 feet. If there are any openings, I can ensure that there are no split markers placed within the openings, so no panels are generated in between an opening. I hit confirm, and you can see in the view we have these markers that are placed consistently throughout the wall. These markers don't physically split the wall, but it will define the split points for the panels. What I can do now is select the wall, go to MWF, and simply create a panel. To split the panel into smaller portions, I can use the markers. I can choose a template, and I can simply create my panels, which will be split at the marker locations. And as you can see, we have our multiple panels generated at those split marker locations. Another method that we can use to split our panels is simply by placing a marker directly in the view and then using that marker position to split the panels. So I'm simply going to go to my components menu and place a component. In the type selector, I can find my split wall horizontal component, and I can simply place this in the view. So I need to make sure I'm selecting a wall, and I can split my panel into smaller portions. If I want to be precise, I can place dimensions to control where I'm splitting to and where I'm splitting from. Whilst avoiding any openings in the process. From there, again, I can go back to MWF and simply create my panel. So another really important aspect of manufacturing our panels and communicating our design is shop drawings. So within MWF, we have the tools to allow us to generate multiple shop drawings at the click of a button. We can select multiple at once, or we can select drawings on a panel by panel basis, but we can generate multiple drawings efficiently and quickly. Each drawing can be consistent, and the layout and other things can be manipulated and saved as a template, which you can use to produce multiple elements at once, multiple sheets at once. In this example, we have our panel, and I'm simply going to select one of the panel members and show you how quickly we can generate a shop drawing. So now that's complete, we can take a look at the drawings that have been generated. For each element that we need to place on our sheet, the views, associated schedules, and other elements are automatically created, and we're able to see those within our sheets. So here you can see that we've got our elevation view, all dimensioned, and all members are labeled in the view, in the panel. You can also see that we have a plan view, also showing a dimension based on the opening location and any hold downs and bolts that are placed within the panel. We have our 3D representation, and we have our framing schedule, which gives us information based on the types of members, any members sharing the same characteristics, length, and quantification. These are only a few of the settings that are available, but there's a wide array of settings that you can use and can choose from. We also have sheathing related drawings as well, and multiple settings that we can manipulate to generate all the drawings we need to extract the data that we need. So again, we have our elevation view, we have a plan view showing the interior orientation, and then we have our gypsum wallboard sheathing schedule. On our exterior side, we have exterior sheathing, and again we have the same information that we can extract from these sheets. So we have our schedule related to these sheathing elements, where we can quantify those elements. We can see the sheet width, height, and also the sheet thickness. All this can be modified using the settings within MWF, and there are multiple settings that we can change to generate different views and extract bits of information that we need. One of the major key benefits of using MWF is that it sits inside of Revit. So as it's a plugin inside of Revit, you can still stay within that Revit environment and still utilize all those Revit features alongside MWF. There's no loss of data, and there's no need to jump into a third-party application in order to get additional information. A lot of the information is still held within the Revit model and still accessible within the MWF plugin as well. I've shown only a selection of tools available to use in MWF, and hopefully these demonstrate some of the capabilities that we have to boost efficiency and productivity. Similar to in offsite construction, we want to create things as quickly as possible, as efficiently as possible, and we want to streamline repetitive tasks in order to get the best output. Overall, when compared to traditional manual modeling techniques using Revit, models can be produced in much less time with a greater degree of accuracy. One key benefit of using MWF is that it's a sustainable option and a sustainable solution. We frame in both wood and LGS, and these are both sustainable materials and eco-friendly. So timber, it stores carbon throughout its life cycle. With responsible foresting practices, it is a reliable renewable resource. And steel is 100% recyclable. LGS framing includes recycled steel in much of its composition. A big part of offsite construction is waste reduction. When modeling with MWF, you get accurate outputs and an accurate model where you can get cut lengths, quantities based on what's required on site and to generate your panels. This information is extremely important and useful when it comes to waste reduction. This is really a great solution when it comes to offsite construction and creating accurate Revit models. So now let's take a look at ONYX. ONYX is a web-based production management tool and a bridge to your CNC machine via Revit and MWF. Just like many of the benefits that are realized through applying offsite construction methods and techniques, there are many advantages and improvements that can be experienced through the use of ONYX. For example, ONYX is easy to implement. There's no need for high-end hardware or even a Revit license. It's extremely versatile and flexible. As ONYX is web browser based, it's accessible from virtually anywhere. ONYX has a high degree of efficiency, and it can improve collaboration and communication within design teams through the use of status updates, exportable tables full of data, and also generating reports within the ONYX environment. ONYX is compatible with a wide range of roll formers and saw machines, as well as nailing and routing tools, amongst some others as well. So what you can see in the view is the wall panels that we generated earlier using the Quick Create tool. What I'm going to do is upload these into ONYX, and we can take a look at some of those tools and how they boost productivity, just like with offsite construction and some of those techniques. So first thing we need to do is link to our project, and we can see we've got a project that was already generated. From there I can select the project and upload any sections that need to be sent into ONYX. In the Upload Manager, we have the ability to upload LGS profiles, lumber, sheathing, and hardware. And you can see that there are some options available. If they've been uploaded previously, you'll see a number relating to the version, if you wanted to upload a new version, for example. After you've uploaded sections, we can upload the panels. So I'm going to select all of these walls, go to ONYX, and upload panels. Once complete, we're open up into a dialog box where you can see a number of panels or a range of all of the panels that we've selected, and we can filter the list by searching for a specific term. So we can search for INT for interior, for example. We can also use the filter criteria, so we can filter by type, by panel type, by host level, amongst some other things as well. I just want to upload all of the panels, but you can see we can check the panels beforehand, so we can check which ones are not uploaded, and we can simply upload all of the panels. We can see some feedback to say how many panels have been successfully uploaded and which panels are wall panels, floor panels, ceiling panels, or truss panels, all of which are accommodated in ONYX. Okay, so this red overlay gives us an indication that these panels are locked and that they have been uploaded to ONYX. Now let's jump into the ONYX environment where we can take a closer look at some of the tools and features in that application. So here within ONYX, you'll notice that we have a project available, and this is the project where we sent our geometry earlier on. We have a range of tools inside of ONYX which will help boost productivity and will improve your workflows. So for example, we can track, schedule, and sort panels using a range of tools such as work orders, sequencing, and the panel manager. So let's take a look at the panel manager where we can see some information related to our panels. So now here within the panel manager, you can see all of the panel types which are filtered or sorted by category. So you can see we have our wall panels, floor panels, ceiling and truss panels, all separated for us to find the information nice and easily. All the information related to our panels is shown in this table, and you can see we have length, height, weight, and other information that we can gather from this table. Any information that we need to share with anyone who doesn't have access to ONYX can be exported using the export to CSV option here, which will generate a CSV file that can be opened in applications such as Microsoft Excel. So when generating our panels, and if we wanted to track the progress of the panels as we produce them and as we download information related to our panels, and just to communicate that effectively with our team members, we have statuses to show when anything updates in relation to our panels. So here we have our profile status. The status for our panels is currently set to new because nothing has changed with these panels. They're still fresh inside of the file. There are 4 different statuses that we can see, and I'll just show you each one that will show up. This makes it easy to track and understand the current status of each panel. And you can see here, all I need to do is select one of the panels. We've got checkboxes on the left, and I can choose panel interior 02W36. I'll simply say download CNC, where I can generate the machine code straight from within ONYX. So you can see the status now says downloaded, and we can see we have a sort order number that has been generated in relation to this being the first one that we have downloaded so far. So the second status you can see here is downloaded, first one being new. Another status that you may see as well when you're working is partial. So the partial status will show up when we don't want to download the whole panel, but we want to download a portion of the panel. So I'm going to go ahead and select a few members of the panel, and you can see here we've selected the top track, bottom track, and the end members, the end vertical members. From there, I'll simply say download CNC, and that will download the members within the panel rather than the whole panel. As you can see, the status for these members has changed to downloaded, and you'll notice when we scroll up that the status for the whole panel is set to partial. There's a fourth status that we'll see when we're generating our panels, and this also helps to communicate the current status of the panels and where we're currently up to and when we're producing them. So what I'm going to do is I'm going to download another panel really quickly. So panel 02W8, download CNC. This will generate a new roll order number, and as you can see that roll order number is number 3. And now when we go to the manufacturing center, this is where we can view all of the active projects, and we can view anything that has been downloaded. So any panels that have been downloaded, we can view. So it could be one panel, it could be multiple panels. Anything that shares the same saw order number or roll order number can be seen in the list here. So we've got saw order number, and we've got number 3, which is the latest one that we've just downloaded. And from here I can set the status of this panel or this batch of panels to completed. And then back inside of our project, we can see that the status now says cut. So that explains the 4 statuses that we'll see inside of ONYX, and it clearly communicates where the panels are up to in the production process. So now we'll take a look at the CNC editor, where we can experience greater manufacturing precision through the use of the CNC editor, where we can modify and validate panel operations, and we can also check the panel just to make sure, do a last minute visual check on the panel to make sure that everything is as we expect. So the CNC editor is compatible with both LGS and wood, so we are using those eco-friendly materials inside of ONYX, and we have operations for both LGS and wood which are available, all depending on the operations available for your CNC machine. In this case, for our wood operations, we have round holes, rectangular holes, slot holes, and we have a longitudinal cut tool option as well. Inside of the CNC editor, first I need to load in my panels. We have some criteria that we can use to filter down the selection. So rather than loading all the panels, I might want to focus specifically on the wall panels. So I can load panels, and then from those panels I can select one in the list. So if I wanted to look at my external panels, I could select the top of the list, the external panel here, which has sheathing boards. I can hide the sheathing and can show just the structural members within the panel. From there, we can view any existing operations. So here we have a round hole, and we have a round hole placed at the bottom of the panel as well. These can be modeled inside of MWF and shown inside of ONYX, as we can see here. Any additional operations that we want to add, we can select a specific member. So maybe I wanted to add a round hole inside of this vertical member. We can select a member specifically, go to our wood operations, select the operation type that we want to add, and then we can specify the location of the operation by dragging it manually, or we can type a more specific value, and that will place the operation there. So once you're happy with the edits that you've made to your panel, you can then save this as a draft, and we can come back to this at a later stage. So it'll be treated as a work in progress. Otherwise, we can publish the changes and we can add those to the panel. We have various tools that you can use to view the code before you've produced your panel. And this may be a useful step if you wanted to just verify that all the operations are where you expect them to be. Any areas highlighted in red are relating to the selected element. So you can see here we have the single member number, and then we have the information in relation to the operations, its location, and a few other things as well. So we've got cut operations, drill operations, and a few other things as well. If we wanted to download CNC, we can do that right inside of the CNC editor. And that is a really handy tool within the CNC editor. So we can download the output straight away. Another tool that I'll demonstrate, which will help boost the productivity of our projects, is the sequencing tool. The sequencing tool allows us to add a logical order to the panels based on how we want to load the panels onto a truck, arrange them on site, or any other user-defined criteria. So in the project viewer, I can go to sequencing, which will open up into this window where we can start to add a sequence to our panels. Just like in the CNC editor, I need to select the criteria for my panels. So for example, I could load only the exterior panels in this case. I could choose to load only the wall panels. So I could uncheck floors and load in only the panels I want from the exterior side. These are the panels that have been loaded in, and from there I can apply a sequence to these panels. We can change the level of detail, and that will affect how the panels show. There are a load of settings that we can utilize. So for now, I'm just going to go to sequencing, where we can apply a sequence by selection. The panels are currently showing red because there's no sequence applied, and we can simply apply a sequence by selecting a panel one by one and apply a sequence in the order that we select them. Once a sequence has been applied to the panel, you'll see a number in brackets just to tell us that this has been assigned a sequence number, and that is useful as a reference. That will also show up in the stacking environment as well, which we'll look through shortly. When you're happy with the sequence that's been applied, you can say save, and that sequence will be saved to the panels. In the event that you want to generate your very own sequence type, we can also apply different types of sequences as well. So we've got the exterior sequence, which is the one that was just active, but we can apply a new sequence using the interior option as well. As you can see, when I've selected the interior stacking, the sequence numbers which were assigned to exterior have been removed because we can add a different sequence number in this case. Again, I can refer back to the filters. I can load in my interior panels in this case, and I can apply a sequence to the remaining panels. Rather than apply the sequence by selection, I can apply the sequence by converting the existing panel ID number to a sequence number. That may be more handy because it will do that quickly, and it will apply the number based on the numbers assigned to the panels. I can choose the sequence type, which is interior, and I'll say convert. Each panel has been given its own sequence number. You can see here, based on the number assigned to the panel, the sequence number corresponds with that. Okay, so that is the sequencing tool. And if you wanted to see an animation related to that, we have the play option, which will play an animation in relation to the order of the panels. So now we'll look at the stacking tool, where we can plan and streamline the panel distribution and logistics through the stacking and bundling toolset. We can plan trips more effectively by getting accurate representations of the size of the trucks, any weight constraints, any size constraints that we're working to as well. What we're going to do is start a new stacking session. So here you can see stacking sessions, and I'll hit new session. From there, it takes me into my window where I can load my panels once again. Just like before, I can decide which panels to load in, and I only want to load in my wall panels. I'll set the level of detail to fine, and I'll just load these selected panels. Now in the view, you can see all of the panels that I've selected, and we can start to place these in containers. The first tab lets us filter the information. Second tab will show us all of the panels that met the criteria that we selected in the filters. Third tab dedicated to stacking, where we'll see all of the containers and all the panels once we place them in containers in a tree view, where it will show us where the panels have been placed. I'm going to go into the stacking tab at the top of my window, where I can add a new container type. So I'm going to say add bundle. From there, we can add based on selection. So I can start to select panels and add multiple panels by selection. I'll hit the plus sign and that will place them within my bundle. We have two views dedicated to our container where we can change this to make it easier to load the container. So we can load them in elevation and we can edit them in plan view as well. We can orientate the view however we like, and that makes for ease of access to the different areas. We can generate different templates for our bundle. So we can have a larger bundle, smaller bundle, all based on your constraints that you're working to. And in this case, you can see that we have a slightly longer one. In the view, I can rotate my panels, so I can select them all, and we have a range of modification tools that we can use to alter the appearance of the panels. We can resize the container as well to fit around our panels if we know that we have enough allowable space in order to do so. Best practice would mean that we would usually make sure our panels fit within the container, within that constraint that we're working to, but we do have a tool that allows us to resize where needed. Once you're happy with the changes you've made to your container, we can simply hit the tick and give it a name. I'm going to accept the default name and I'll say add, and we'll see the container that's been generated. So we can generate bundles, pallets and trucks, and we have methods in order to place different things in different containers. Maybe for these remaining external wall panels, I want to place these in a pallet instead. So I can select the panels, drag and drop, and you can see those are placed inside of the pallet. If I wanted to lay a panel next to an existing one, then I can actually use these edit tools to move things, rotate things, and remove any gaps in between. So we can use the collapse tool to remove any spaces. Once we're happy with the changes, we can then hit the tick again, and we can call this ext to represent the fact that it houses those external panels. Maybe we would like a quicker way to load our panels into containers, and we have different methods to do that. We have a stack by path tool where we can draw lines to place our panels inside of the container based on the panels that the lines have passed over. In order to use stack by path, we need to first generate a bundle or a pallet or a truck, and then we can activate the tool. We can select elements based on their category. So in this case, I've categorized the panels as external or exterior and interior, and I'll want to select the interior panels in this case. From there, it opens into a plan view where we can start to draw a polyline, which will pass over my panels in a specific order. So maybe I'll start from this left-hand corner, and any panels that this line will cross over will be applied to the container. Once you're happy, you can hit the green tick and it will load the selected panels into the container that you've selected. Again, we can make any modifications that we need to. We can resize the container. You may want to remove the larger panel in this case and stack that with the other larger panels. That's totally fine. But in this case, I'll just accept. We can also stack panels by sequence. So stacking by sequence will take the sequence numbers assigned to the panels and it will stack them in the order that they've been sequenced. So I'm going to click Stack by Sequence. I can choose the size of the container I want to use. In this case, it's referring to my bundles, and I'm going to select a larger bundle. I'm going to say Set, and then I'll define the sequence type that I want to use. So these were numbered using the interior sequence, and I'll say Set. It's just giving me a heads up that all of the panels that have been sequenced aren't all being contained or aren't all being placed in containers right now. That's okay because some of the panels are currently hidden in the view. We have floor panels as well, which are currently not visible in the view. So for now, we have all of our panels or wall panels placed in containers. We can make any last minute edits very easily by clicking on Edit, select a container, and we can make an edit to the selected container. In this case, I just want to resize these elements or resize the container, and we can go ahead and do that. We have tools which will restack the panels as well. So rather than stack them in order, maybe you just want to stack them in a way that is easy to transport. So we can reorganize the panels in a way that will make the stack a little bit more manageable. So now we've generated all of our container types. We're going to want to place these in a truck so we can transport them to site. So I'm going to quickly modify this one, and I'm going to add a new truck. So I can say add truck, and this is my truck size, where I can now start to place all of my containers by dragging and dropping them into the view. And I want to reactivate that so I can start to load it with the panels again. So again, I can drag and drop these elements into either view, and I can change the positioning if I want to. So in this case, all the panels may not fit in the first trip, which is fine. And at least we're aware of that because we can see that representation in the view. If any clashes are to occur inside of the truck, you can see here that it highlights red just to tell us that these elements are overlapping and that there isn't enough space to house both of them. Okay. So once you're happy with your truck, you can check all the different areas. You can also move all of your panels if you want to. And we can confirm the truck just like that. I can add a second truck where I can drag the remaining panels onto that truck. And again, I can make some adjustments to these elements by using rotate and the move edit tools in order to position it however I want. So now we have our two trucks loaded full of panels. We can go to general, we can save this as a draft, and we can also publish the session. If we save as a draft, it's a work in progress that we can come back at a later stage. But if we publish the session, we can then generate a report from it. So I'm just going to call this one Offsite. Click OK. And I'm going to simply go to my stacking center where I'll be able to view the information related to this project. So we've got our bundles, and if I select one of the bundles, I can see the panels which are contained inside of each bundle. If I wanted to see the pallets and anything contained within the pallets, I can view that information again by selecting a pallet and seeing the information at the bottom here where it separates all of the elements. And for our truck, we may want to view all of the elements within the truck. We have two trucks available, and we can view the contents of each one. And we can break that information down into panels, which panels are in bundles and which ones are contained, which panels are inside of pallets, inside of the truck. So maybe I want to generate reports to show this information to a third party or give this, feed this back to a member of the team. I can generate a report for the selected elements or a report for all of the elements. It will give me a breakdown of all the panels inside of bundles, inside of pallets and trucks. In this case, I want to see an overall report giving me all of the information in one place. So I'm going to say generate a report for selected. I can open up the report, and from there we can see a breakdown of all the information that was contained within the report. By utilizing ONYX, we can track, schedule, and sort panels. We can manage and coordinate data. We have greater manufacturing precision, and we can plan and streamline processes using the range of tools that are available. I've only demonstrated a few of the tools available, but there are an extensive range of tools that you can still utilize, which I haven't demonstrated, but hopefully that's given you an indication as to how ONYX can work or could possibly work for you. I hope you enjoyed it. That's all from me.